In this second part of vocabulary of a line, we're going to look more in depth at intercepts and how do we find intercepts from the equation of a line. We're also going to look at different types of equations that relate to parallel and perpendicular lines. So the first thing I want to do is take a little detour from the notes portion of it and look at Desmos so we can graph an equation that's in what's called standard form, where the x's and the y's are on the same side and then we've got another number on the other side. And we'll use this to give us an idea of how to actually find x and y intercepts. So I'm going to type an equation in standard form, 2x minus 3y equals 12. And I like the number 12 because it just gives us a lot of good stuff to find. So a couple points immediately jumped out. As soon as we graph that equation, this point right here, 6, 0 is our x-intercept, and that point down there at the bottom, 0, negative 4, is our y-intercept. The value is actually the intercept itself, but the coordinate represents that point. So looking at the equation, we try and figure out, is there an easy way that we can get 6 for the x-intercept from this equation? And the reality is, if you look at the x-intercept, the y-coordinate will always be 0, no matter what. So when we have an equation like 2x minus 3y equals 12, if we're trying to find the x-intercept, we can effectively ignore the part that has the y. That becomes 0. So basically, we've got 2x plus 0, okay, great, we won't do anything with that, equals 12. So if 2x is 12, x has to be 6. We do the same thing for the y. If we're looking for the y-coordinate, or the y-intercept, the x-coordinate must be 0. So right here, that part becomes a 0. The 2x is effectively gone, and we're left with negative 3y equals 12, which is negative 4. Now, the reason we need this is we're going to take a look now at, from equations, we're going to be asked to describe certain things, to pick out certain characteristics. So when we have the equation 6 minus 2y equals x is graphed in the xy plane, which of the following is true about the graph? Okay, so the first two choices mention something about the x and the y-intercept. So very possibly that might be something that would be beneficial for me to look at. I'm going to start going with that. And it seems like both of these have something about x equals 6. So I'm going to maybe effectively ignore that right now. And if I want to find the y-intercept, that x-coordinate is going to become 0. So I'm going to set up an equation and then try and solve it to see where I'm at. And so to solve this equation, if I take away 6, I'm left with this, and divide by negative 2, my y-intercept is 3. And based on my choices, that doesn't look like, you know, A or B are going to work, because they have different y-intercepts altogether. So let's go back then and take the equation and rearrange it, because the remaining choices I've got have some mention of slope, and either it's a negative 2 or it's a negative 1/2. So looking at the equation 6 minus 2y equals x, in order to find out the slope, probably the best thing for us to do is to get y by itself. And so I'm going to move 6 by subtracting it. Negative 2y equals x minus 6. And just remember that x is a 1x. Next step is I'm going to divide by negative 2. And again, a 1 divided by negative 2 is negative 1/2. And negative 6 divided by negative 2 is positive 3. So the slope then would be negative 1/2. If you notice, when we rearrange that equation, we actually found the y-intercept also. So we had it here, we had it when we started off with the problem and set x equals 0. So same kind of idea, but just a different approach to finding the problem. Okay, next question. Which of the following is an equation of the line in the xy plane with an x-intercept of negative 2/7 and a y-intercept of 8/7? So again, to find an x-intercept, I'm setting y equal to 0. So looking at my choices here, by taking y equal to 0, these are the equations I'm left with. Negative 28x equals 8. 28x equals 8. 28x equals 8. And negative 28x equals 8. So based on the fact that I'm looking for the x-intercept, I know it's going to be a negative number. Well, I know it can't be B, and I know it can't be C. And I'm going to trust that if I were to take that negative 28 and divide it in both sides and reduce, that my x-intercept would be negative 2/7. But I'm not really going to go through that whole process because if you look at my choices A and D, they have the same component. So my guess is that unless this is an unanswerable question, we're going to reduce down to negative 2/7. Now, if I'm looking for the y-intercept, I'm going to do this in a different color. And the y-intercept, we're looking for x equal to 0. So in this case, I'm going to have 7y equals 8. And down here, I have negative 7y equals 8. Now, that one would be relatively easy to solve. I just divide by 7. But it would have to be A, because that will give me a positive 8/7 versus choice D, which gives me a negative 8/7. And so that's how we might use intercepts. If you're looking for the x-coordinate or the x-intercept, the y-coordinate is 0. If you're looking for the y-intercept, the x-coordinate is 0, and so on. What about parallel and perpendicular lines? So parallel lines, if we were to graph them, they would look something like this. A little bit more straight than that, but you would get the basic idea. They're going to move up at the same rate. So their rate of change is exactly the same, which means their slopes are going to be exactly the same. What they're asking us to do is find an equation of a line that passes through 1, 1 that's parallel to this line. Well, the slope right now is negative 3. So if we're looking at a parallel line, it's got to have the same slope. So these have a slope of negative 3, these don't. So A and B are out of the picture. There's no way it could be those. So next what I'm going to look at is how do we finally figure this one out? Well, there's a couple ways that we can do this. Knowing that it has to go through the point 1, comma 1, I could, if I wanted to, use slope-intercept form, but I think I'm actually going to use point slope to help me figure out which one it's actually going to end up being. Or what we could do is we could take the point and plug it in and see which ones are true. And that might be the easier choice here because we don't have to plug into an equation, distribute, rearrange, turn it into a different form. It might be easier to just take that point and plug it in. So when I plug 1, comma 1 in here, so I'm going to plug y in for 1 and 1 in for x, what I'm going to get is 1 equals negative 3 plus 4, which gives me 1 equals 1. That's a true statement. So I'm thinking it's probably C, but let me just verify that it's not D also. When I plug that into there, 1, 1, I'm going to get 1 equals negative 3 plus 1. So 1 equals negative 2. That is definitely not true. So again, a point being on the line means it makes a true statement when I plug it in, and C would give me that correct answer. Perpendicular is a little bit different. It's a similar idea that it has something to do with the slopes, but a completely different concept. So if we had a line like this, the perpendicular line would look something like that. They form that X. Now, visually, you're not going to be able to see this. We can derive this algebraically, but the relationship between perpendicular lines is their slopes are not the same, but they are what are called opposite reciprocals, which means when I take this slope of negative 1/8, the opposite reciprocal of that would be positive 8/1. And so A and C are not going to be legitimate choices. And so now what I'm left with are either B or D, which look almost identical, but a different sign in the y-intercept. Let's take our point negative 5, 3 and see which one actually works out. So I'm going to take the 3 and plug it into here. The negative 5, plug it in for x. And so I've got 3 equals negative 40 plus 43. And so 3 equals 3. That is a true statement. But again, we just want to double check and make sure that when I take that point and plug it into the other one, 3 equals 8 times negative 5 minus 43. And think it, oh, if I could write, I get getting a little ahead of myself here, knowing that's not going to work. When I've got negative 40 minus 43, that's negative 83. So those numbers aren't even close. B would be our correct answer there. So let's use rate of change to help us solve some problems. So this one here, during a major snowstorm, snow fell at a rate of approximately 1.8 inches per hour for 5 hours. So we're starting off, and this might give it away, that when we start measuring, there's actually no snow on the ground at all. Which of the following graph represents the relationship between total snowfall during the storm in inches and time? So every hour, we're going to add 1.8 inches to the total. Our vertical axis right here, the S, represents how much snow has fallen during the storm, not just on the ground, but during the storm itself. And then our horizontal axis here, T, is our time. So if we just kind of reason this one out, we might be able to easily pick out the correct answer. But think about this. If the storm has just started, there's no snow on the ground yet. So in theory, we should start at a height of 0, and you might be leaning towards the correct answer already, which would be A. But if you're not, we can also double check some various points here. If it's falling 1.8 inches per hour, we know after 1 hour, we should be at about 1.8, maybe just slightly short of 2. So if I go to a x or t coordinate of 1 and follow that up, I've got about 1.8, and C also follows that as well. B is going to be too high because that's almost 4, and I don't know what's going on with D there, but that's not good news. Oh, it seems like the snow is like evaporating. Anyway, going on, I can go then, well, after 2 hours, I know that 3.6 have fallen because it's 2 hours have passed. It's an additional 1.8 inches. So if I go to 2, 3.6, that one seems a good, oh, and there we got a problem because it seems like on this one, 1.8 inches fell immediately and then nothing happened until the end of time. So A would be our best choice in that case. And let's do one more quick one here. Yeah, that's a good one. So Anatoly is keeping track of the salt supply at his restaurant. As of May 1st, the restaurant had a supply of 7.5 kilograms of salt. So that sounds like an initial value, possibly. He estimates that the salt supply will decrease linearly and become empty in 20 weeks. Interesting. Which of the following graphs represents S, the restaurant supply of salt in kilograms, as a function of W, the number of weeks after May 1st, if Anatoly is correct? So the fact of the matter is we are starting then, because May 1st is when we begin, our vertical intercept then should be 7.5. So we should be looking for a point of 0, 7.5 for a beginning point. And then it's empty in 20 weeks. So again, the weeks are our horizontal axis. We would expect our supply then to be 0. And based upon just those two pieces of information, our best choice would be A. Now, I could see how we might pick C because it's just got the axis flip-flopped. But we start at 7.5, we work our way down to 0 after 20 weeks. That would be the best one. So those are the types of things we're going to use to determine our rate of change to figure out which graphs would best approximate those.